Record. And we're rolling. Okay, welcome students to the back half of the Chapter 5 in-class review. It's Mr. Thayer, and let's take a look at number 4. In number 4, we want to solve this problem by rewriting. So I'm going to pause. Let's rewrite this as a common base of 2. Like 4 is the same as 2 to the second power. And I'll put the 2p outside of that. 32 is the same as 2 to the fifth power. Is that correct? 2 times 2 times 2 times 2 times 2. Is that 32? And put the negative 3p minus 1. Now that you've achieved same bases, we can rock the power to a power property and make this 2 to the 4p and 2 to the 5 times these pieces, or negative 15p minus 5. Now, since the bases are the same, what exists in the exponents must also be the same. So I'm going to forget about the bases for now and just focus on the exponent part. They have to be equal to each other. So now you're just solving a problem with variables on both sides. So I'm going to move my variable to one side. 19p equals negative 5. And that would mean p equals this really pretty rational number of negative 5/19. That would be our answer right there. Very good. I'll pause here for questions. Okay, next, let's take a look at part B, where we have a bunch of fractions. So it'd be ideal to get rid of these fractions by multiplying by the least common denominator of the entire problem. So I have a denominator of 4 and 2, and the least common denominator between those is 4, right? 4. So we're going to multiply this whole problem by 4. All right, I've distributed the 4, and we do that so we can now simplify our fractions, which will now be nice integers. So that'll just become negative 1x or negative x, and this will become a negative 2x. Everything else I'm just going to drop down as 12x plus 36, 4, and your plus 32. Next, we'll combine like terms. So I've combined like terms, and now I've got variables on both sides. So I'm just going to rewrite my problem over here and move my variable terms by adding 2x to both sides. And that'll give me 13 2x. 13x plus 36 equals 36. So the 36's will essentially cancel. You'll have 13x equals 0. And that means x, after all this hard work, is equal to 0. Pause here for. All right, welcome back. We are now going to solve for part C this problem in 2 different ways: distributive property and area model. So when you make an area model, what that means is you're going to place these 2 terms in a 2x2 box. So go ahead and make your 2x2 box, or rather they're going to go on the outside of the 2x2 box. And then you're going to multiply them together. So I'll do x and a positive 4, x and a positive 3, and multiply these together to get x squared, 4x, x times 3 is 3x, and 3 times 4 is 12. Now you can combine these like terms. So on the left side, you'll have x squared plus 7x plus 12 equals, let's use the distributive property on this side. So x times x times 1, 2 times x, and 2 times 1. And you can combine that to make 3x plus 2. Okay, so here's the cool thing. Those x squared, since they're both the same on both sides, those just cancel out. So those are gone. You can move them by subtracting, or you can just cross them out. All right, let's move this variable to the other side. Let's start to solve this problem here. 4x plus 12 equals 2. Take away 12, take away 12. I'm going to pause my recording right here. All right, awesome. So we finished solving for x. I got a lot of right answers in the chat. You could write this as negative 10/4, negative 5/2, or negative 2.5. It's all good. All right, in number 5, our mission is to create an explicit equation based on the information we have. It looks like we have the information for a recursive equation, and we got to get the explicit stuff from this. All right, so what we want to first identify is that this is an arithmetic sequence. How do I know that? Because I see a common difference right there of plus 6. So I know D equals 6. And my mission is to write an explicit equation, right? And I see T of 1 is equal to 3. So that means T of 0 If I were to work this pattern backwards, if my first term is 3 and my common difference is 6, it would go something like this, right? Well, I need t of 0, so I'm going to work backwards. What would t of 0 be but take away 6, right? So wouldn't that be negative 3? So you want to write an equation that looks like this. So our equation is t of n equals 6 times n minus 3. That is your explicit equation. I identified the common difference. I worked my pattern backwards from t of 1 right here, or right here rather, and went backwards to get t of 0. And that's how I got the pieces I needed. Next, is it possible to have 369 a term value? Well, a term value is t of n. So just plug in 369 in place of t of n and solve this for n. If you land on a whole number, then yes, it is possible. If you land on anything but a whole number, it's not possible. So if I add 3 to both sides, that's 372 equals 6n. Divided by 6, divided by 6, what will that give me? All right, we got n equals 62, which means 369 is the 62nd term in your sequence. So yes, it is possible. All right, number 6, we got to write a slope-intercept equation from 3 different scenarios, 2 points, a table, and a graph. So when you have 2 points, the first thing you want to do is find the slope by subtracting the y values from each other and subtracting the x values from each other. So that'll become negative 2 over 1. Your slope is negative 2. Next, take any one of these 2 points and plug them in place of y and x in slope-intercept form. So I'm going to put negative 1 in for y. I'm going to put 2 in place of x and solve for the b variable. If you add 4 to both sides, b is equal to 3. So your equation is y equals negative 2x plus 3. Okay, next, in this table, we want to write a slope-intercept equation. The very first thing you want to search for is, do you have the y-intercept? Yes, you do. When x equals 0, that's your y-intercept. So you've got plus 1 in your equation right there. And now we'll find the slope of this table. That can be found by finding how y changes, that's adding 2, compared to how x changes, that's adding 1. So the slope is positive 2 over 1. And there's your equation from the table. Let's move on to the graph now, shall we? The y-intercept is the point where your line crosses the y-axis, so that's positive 50. The slope can be found by looking at another, quote, pretty point, like right here, and finding the rise over the run. So that's up 50, 75 divided by, looks like 125. Now you could write it like that, but you could also reduce that down, can't we? And what does that reduce to? What would that slope reduce down to? All right, that would be a slope of 3/5. So y equals 3/5 x plus 50. And that's your third equation. Last but not least will be number 7, coming shortly. All right, so I have used my Desmos calculator tool. And using that, I've come up with the least squares regression line equation of y equals approximately 0.15 x plus 44.48. All right, so now that I've got that, I also have a correlation coefficient. That's the R value, which is approximately 0.7642. And that means we are, moderately strong, we are positive, and we are linear. And then the slope in this situation is 0.15 over 1, which means 0.15 in your score per 1 breakfast calorie. So more calories you eat, the more you boost your score, apparently. All right, hope this video helps. Have a wonderful day.